Yeah, okay, the video's working. So the question was, what would the test look like? It's going to be like the exact same general format of what you're used to. No curveballs, no nothing. Same general idea. This particular upcoming test, it's going to kind of follow that format of like that short answer. There's no short answer anymore. Remember how I did that, like where it would be like quick ones like, write a function to add two numbers together and return the result. Yeah, you ain't getting those anymore. Those are gimmies. You don't need those anymore, right? So the questions are going to be short answer, which are going to be like the longer ones that you were used to. Like, remember from last semester, like we could think of the exam, like do a linear search for the index of the largest integer, right? Like that type of thing, right? On those questions, if you find yourselves writing like lots of code, you're doing it wrong, okay? These are supposed to be, I don't know, like something like that is, okay, you've got a variable to keep track of the largest integer, the index of it. You've got a for loop. You've got an if to check the condition. You update the two variables, and then you return at the end, right? So like, you know, that would have been like, you know, 7-ish lines of code, not counting a header and squiggles, right? So like that, you know, that type of level. If you're writing a lot more than that, if you're writing like 20 lines of code for one of these questions, stop. You're doing wrong. Remember, half of what I'm doing, like the art of writing a good test is writing a test that evaluates your understanding while also being easy for me to mark. So it's the type of question where like I want to be able to look and be like, yes, no, yes. And when you're wrong, it's like, okay, they messed that up and that up, right? So it's nothing overly complex. If it was anything I really need to tease apart to mark, I'm gonna be mad, right? So anyways, and then do you remember how like the final exam from 161, there was like, there was that part on like classes, how there was another section that was basically like the short answer, or that was basically like the short answer, but they were all about some classes. It's gonna have that idea, right? Same format as 161. It's not a new format, just same idea. Other questions about that? Thanks for asking that though. And it'll be here next week, right? Yeah, cool. We'll make sure everyone's spaced out nicely. I know there's not a lot of room because of the computers, but we'll be fine. No other questions? Everyone's happy? All right. Okay, so we were talking about unit testing again. And yeah, we tested things like the country object, the friend object, the course object, whatever. Not too bad. But and you all did last week's lab, right? So there was the testing for those ones. So those ones are nice and maybe easy is not the right word, but straightforward to test, right? But now we've got that mutable, stateful, interconnected methods. Like, it's tough to test. Like, how can I test remove without having, like, how could I test push? Or I guess more appropriately, how can I test pop if I don't have like a working push? You know, like I can't do that. They're stuck. They're you know. So this is very difficult to test, and you know the way, like the behavior of the object is going to be different depending on its current state. Like I was saying, pop is going to work differently when I have an empty stack versus when I have, you know, one thing in it versus what happens when I've got many things in it. Although those last two are kind of similar. The point is, it depends on the state. So there's a lot of different states and everything we have to keep track of. So to simplify the process, we want to focus on one state at a time. All right? I highly recommend you follow this strategy. Let's test one state at a time. Okay? So what state should we start with? Let's start with an empty stack. If I have an empty stack, for example, the two push-related tests. Okay, yeah, consider, for example, the two push-related tests. There's a test that returns what is expected. There's also a test with the proper side effect. Okay, this is an example of the added complexity of testing a method with the side effect. Okay, what do I mean by this? I'm testing push, but I have two methods for testing push on an empty stack. Right? I've got push, empty, returns true. right? Because what does this method do? Well, it takes a okay, push empty returns true. We create this array stack of integers called class under test. This is a common name, class under test, for whatever we're testing, right? What should its name be? Whatever you want, but this is a pretty good name because anyone looking at this goes like, oh, that's what I want to test. So create a new array stack, and I assert true that when I call class under test and I push 11, I better get true back, right? Great. But also, it's not just that this method returns true. When I push something onto a stack, yeah, I should get true back, but the state of the stack should change. What should be the case? Well, this is kind of tricky. We might say like, well, should we check that its size is 1? Should we check that, like if I pop, it would work after? There's a lot of options here, and this is actually tricky. Like, how best do you test like the state of it now? And here's a very simple way we're going to do. All right, we're going to use peek. So we create a new array stack. This is push. Remember, method, state, condition, what we expect. Okay, push empty, we get a new top. What's the new top? Whatever, it doesn't matter. The fact is we have this new top that's the same. So array stack, class under test, we create a new array stack. We push 11. Yeah, it returns true, but I don't care anymore because that's what this test tested. You might say, why don't you assert that that's true and assert this at the same time? You're not wrong. You could have multiple asserts in your tests, but remember, yeah, the point of these unit tests is you want each test to test one thing. If I had 2 asserts in here and this test failed, what went wrong? Well, one of 2 things. Exactly, right? That's not so bad, but what if this test failed, I know it's wrong. If this test fails, I know it's wrong. So it's always nice to have one test. So we push on an 11, and then I'm going to assert equals that I get 11 back when I peek. You might say, well, that's kind of like I could have done pop. I could check size. There's a lot I could do, but how best do I test its current state, right? And there's no real easy answer. I kind of have to go about it through a roundabout way, and I've chosen to use peek here. Just push 11 and peek at the top. Is it 11? Okay, it's there. Great. You might say, but shouldn't you test that size as 1? Yeah, but let's save that test for a size test. You'll see in a moment. Okay, pop empty. So what happens when we pop on an empty stack? Well, we want to create a new stack, and then assert throws. And we've got some funny syntax here. This is one of those annoying situations where this is kind of the magic code you have to write. It's because this wants to check. Like this right here, when I call class under test.push, that returns something. But an exception isn't returned, it's thrown. It's a slightly different thing. So we have to use like some weird, funny syntax, okay? I know it's kind of annoying, but this is the magic code we do for checking if an exception was thrown, right? So if I pop on empty, I want to check that I get a no such element exception. Create a new stack, it's empty on default. Assert throws that, and this funny syntax, it's just the way it is. This creates a lambda expression. Don't worry about it. It's just the magic code. I know it's kind of annoying, but it is what it is. Assert is empty, is empty, when it's empty, returns true. Create an array stack. Is it empty? Yep, better be. Size, empty, returns 0. Create a new array stack. Assert equals that we get 0 when we call size, right? And then finally, toString empty returns an empty string. Now, actually, this is interesting. Yeah, that makes sense, yeah. Because I thought, like, should it have a one lone comma? But no, the comma was only ever added if something was in that loop. So I've tested all my methods, right? I've tested, oh, I forgot to mention the peek one. When I peek and it's empty, I get an exception. But I've tested push, pop, peek, is empty, size, toString. You might say, well, you didn't test equals. Testing equals on collections is very difficult. So we're going to come up with a bit of a cheesy equals test that really isn't sufficient. If you were to go through what I have here, I might not even have one here. I may have excluded it. Yeah, I think I excluded it for the sake of simplicity here. Yeah, we're currently excluding the equals test for these two collections because it's complicated. We'll see some examples of this more as we go, but we're not going to talk about that right now. Turns out checking if two collections are equal is actually pretty challenging. Any questions about these tests? You know, we check all the methods we really want to check for the empty state. All right? Great. Yeah, and to hit the point home, like, the method has a return, but it has a side effect. So that's why we're checking this, and we're checking this, right? Well, what was the side effect? That, well, something was actually added to the stack. All right, in the above test, the name of the reference variable was class under test. This is a nice common convention to use. You may notice that all of these tests all start with the exact same thing. Create an array stack, right? Not that big of a deal. Each one has one line. But whenever you have common setup code, it's common to do something like this. Now, I've made, because, you know, when I create it here, this has scope to only in this class, in this method, right? Why? Because it's declared inside this method. So what I'll do is I'll actually declare it outside anything, so it becomes effectively like a class field. And then what I have, I've got this funny little tag that's like at before each. This is an IntelliJ thing that says, basically, before each method you run this code. All right? It's kind of like you tack that on before each one. Okay? And so what are we going to do? Well, create a new array stack. It'll make a new array stack before each test. Great. And then in here, these tests are even simpler, right? There we go. Isn't that nice? That's nice. Yeah. So what am I saying here? Notice that the common setup code, to help simplify, the setup code can be moved to its own method, annotated with before each. Make sure that it acts actually a field for the array stack test class, right? So we moved its like declaration outside. Because remember, this is the declaration, and this is the assignment, right? Here you're like, well, what's what? Well, this line is doing two things. It's declaring and assigning in the same line. Not uncommon. Yeah. Any questions about this common setup code? Cool. If we go over here, you will see, well, ignore this for a second. And we see this like before each, and you're going to see this. Wait, what's going on here? You know what? Let's come back here in a moment. All right. So now let's check the other state. Sorry, another state where when we have one thing on the stack, how should it behave? There's going to be a lot of similarity with the general case here, but you know there'll be some nice conditions we can check here. So here is all the unit test for all the methods in the array stack class. Why am I not wearing this? The array stack class when there's a single element on the stack. So notice the inclusion of a new class field called pre-state. Yes. This pre-state, so I've got private array stack integer class under test, but I've added a new one called pre-state. And what pre-state is I'm going to make basically a version of my class under test that is like, well, this is what it looked like before I did anything, and this is what and then class under test, I'd like maybe push something to it. So now they would be different, right? And that's going to come in handy for testing purposes. Remember that all of what I'm showing you is my like recommended coping strategy. Nothing about what I'm showing you is like the definitive, this is the correct way to do all of this type of stuff. That's not really true, but this is a darn good way to do all this stuff. All right. Pre-state, So, for example, consider peak singleton unchanged. Calling peak should leave the state of the class under test unchanged, right? So I should be able to call peak, and then pre-state and class under test should still be exactly equal, right? Right. All right, so although pre-state is only ever actually used for one test so far, it's always convenient to have this like extra field there. This is a convenience thing. Again, it's not the correct way to do this, but it's a darn good way to do it. Okay? So we've got this pre-state. Now my before each creates the instance of the pre-state. And now all of the singleton tests. Push 10, assert true. Here's the push test. Push singleton returns true. I push 11, true. Okay? Push singleton, new top. Push, class under test. This is the singleton setup. And then class under test, I push 11. Assert equals 11, class under test peak. You might say, what's the point of including the pre-state in this one? You're right, it's not used here, but it's a consistency thing. Pop singleton, empty stack. So, push. If I pop the 10 off of the class under test, it should be the case that the class under test is now equal to an empty stack, right? A stack with one thing on it, I pop from it, it should be empty, right? Yeah. Peak singleton returns the talk. Peak singleton unchanged. This is the only case where we do pre-state. Did I do the pops? Yes, I did the pop. Yep. Is empty singleton returns false. Size singleton returns 1. So this is my way of saying, like, remember how when we talked about the empty and you push, why don't you check that the size updated? Here's where I checked where the size updated. Is, well, what's the size when it's singleton, right? Yeah. And then the two-string should look like that, if it was working correctly. Any questions about all this? Ask now. It's better time to ask now than later. Okay. So, what am I saying here? When considering peak singleton returns top, it may become clear that push empty new top and push singleton new top are actually entirely redundant. Peak singleton returns top, and push on empty is a new top, right? Here's a push empty new top. I push 11 and I checked that 11 was actually added. But here was my peak singleton returns top, is push 10, the assert, it's this. You'll notice that these tests are exactly the same. The only difference is what literal I put in there, but that doesn't matter. See? They're exactly the same. Y'all are far too quiet today. Even when I walked into the room, it was weirdly quiet. And you're making me uncomfortable. What's going on? Wake up, come on. See, they're exactly the same. Yeah, the literal, but it's the same. Why? Well, because the spirit in how I have to test these things is the same. Remember, all of these methods are so interconnected when you have such a stateful thing, it's kind of the way it is, right? I'm testing the same thing, or I'm testing two different things the same way. And this really highlights the interconnectedness of all of these methods. Now, you might say, yeah, we could eliminate one of the two of them. I would recommend you don't, because the code speaks for itself. If someone sees, oh, okay, I'm testing that case, it's very explicit that they wrote a test for that case. Unless I had really darn good knowledge of your class that you're testing, and I looked very closely at all the tests that you'd write, I might be like, well, you never checked peak on the singleton. And then you'd come back being like, well, I effectively did here. And I'd be like, maybe explicitly put that test in there just because it's kind of nice to see. right? Because it's a named thing. Yeah? Now, if this fails, this will obviously fail. And if this fails, this will obviously fail. I get that. But remember, the spirit of the code is for other humans, right? Eliminate all the guessing that the human would need to make. Make it as painfully obvious. Yeah, they're the same, but it is what it is. Yeah, okay. Now, the next thing, nested test classes. So once again, you might notice that the setup code, push, 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 there's common setup code for all of these methods, right? But the setup code is different. Like, we couldn't throw this into the before each here, because that would mess up all of the empty tests, right? So before all the empty tests, I want to make an empty array stack, just like this, do all the tests. Then I want to have like another before each, where I push onto the stacks, and then do all the singleton tests, right? That's what I want. So we need a way to do this. This is what we want to do, but with the syntax we have here, we can't really do it. But there's a simple trick. You might not love it, but it is the way we got to do it, is we create nested classes. All right? Where, okay, before everything, create an empty stack and run all these tests. And then we create a new test class inside of that class. It's weird, but it's what we do. Where everything outside is still like there, like that before each is applied, where you create an empty stack. But then inside of there, before all of these tests, we're going to have our own before each. That only applies to these ones, not those ones. So I'm going to start by creating we didn't need this before, but I added it for, niceness, is nested, @nested, it's a tag, class when new empty, we have all of the empty tests. Then, after that, I create another class called when singleton. And then, before each of these, class under test already exists because of the before each from right here. Now, before all of these, we're going to push 10 onto the stacks. And then we'll do all the singleton tests. With nested test classes, there's a way to add another before each that only applied to the things within that nested class. Further, this strategy really helps. If you don't like this, you're going to love it pretty soon, because it really helps with logically separating the state parts of the tests. Like, here's all the empty ones, and then in the nested class we have the singleton ones, because a singleton is like a special case of an empty one, right? And then inside of those, spoiler, we're going to have another nested class for the many, right? Where we've got more. So that's even a more special case, right? So we've got these nested class, and we'll have this before each that applies to all of them. We'll see. So below is an example. Before each, create stack. Now we've got this class when new empty, all of those. I've excluded the remainder here for brevity. And then nested when singleton. Before each, add singleton. Push, push. We have all our singleton tests, but they're a lot simpler now, where we don't need to include those two pushes, because all of the pushes that were in these are moved up to that before each, which is pretty cool. Yeah, at least you're pretending you're smiling and nodding for me. I love it. Keep doing this. This is one of the, by the way, how many of you are first year? Okay, here's if you want your profs to love you, all you have to do is, when they look out into the class, if you're the one in the room going they're going to be yes, thank you. They're going to love you so much, okay? And I don't know what happened. You go back 10 years, usually you'd have a lot of like smiling and nodding. And then something happened where usually now when you look out, you just see this. And it's very difficult because you always kind of have to gauge. Like when the room's smiling and nodding usually means like, okay, everyone's understanding, good, we've got the flow, right? Because this is a two-way street here, right? And when you see the blank faces or the like, you know, you can sense, oh, okay, I should focus on that more, right? It's a very dynamic experience being in the front of the room. But when everyone is like this, I have no information to go off, right? So I go like, I guess you know what's going on. I don't know. Yeah. Sorry? That everyone's happy? Well, figure it out and then get happy. All right, anyways, just keep smiling and nodding. I'm loving it. You're doing such a good job. It's been years since I've seen this. This is wonderful. All right, so there we go. There's the singleton. And now for the general case. All right? Now, we do have to add like this funny little like thing here. Let's not worry too much about it. But we're going to have another nested class inside the singleton nested class, which was inside the when new empty nested class, which was inside the test or array stack test or test array stack, whatever I called it, right? So we've got a number of, right? But if at any point you're like, that's too much, slow down. Every one was nice and logically separated. So it was good. We like that. All right, so we've got another one here. We need this new tag. It can't just say @nested. It needs like, okay, where's the test instance? We have to specify this. We're not going to worry about that. It's the magic code, okay?
Lots of magic code to do.
Yeah, there is. Well, because a lot of this stuff, too, is JUnit specific, which is not Java. There's Java, and then the good people at JUnit, I don't know who they are, made JUnit, right? That works with Java, but it's separate, right? And so this is a lot of, like this type of stuff is how you're using JUnit, which really is a separate thing from Java. So yeah, there's a lot of like, here's how to use their code, right? None of that's really computer science, but it really is helpful for us to know these things. All right, so create stack, okay, array stack, nested, when new empty, all right. One singleton, we've got our before each here, we push 10, 10, whatever. And now we have @nested, and then this magic thing we need here, class when many. Now, you will notice we've got another before each, okay? But we start pushing 10, 30, 40. But the 10 is already on these stacks. Why? Because it exists from the before each outside all the nested classes. And then we pushed 10 onto it in the before each before all the singleton ones. So this before each here applies to everything inside the when many nested class. Cool. All right. I'm glad it does because that makes more sense logically to me. So like it makes sense. All right. So now we've got two stacks with 10, 20, 30, 40 on them, right? Great. So push, how should push work? It should still return true. Pop returns top. Oh wait, push. Yeah, okay. Push, pop returns top, pop. Many, we get a new peak. Basically, when we pop the 40 off, there damn well better be a 30 underneath it, right? Otherwise, it's not working properly. Peak, many returns top. Peak, many unchanged. Is empty, many returns false. Size, many returns correct size. ToString, many returns correct string. It looks like I may have forgot to do a push many new top, right? I'm actually curious. Do I have it in here? Yeah. No, peak, push, many return. Yeah, I guess I forgot to add a push many new top, right? Because here I've got a push singleton returns to pop. Oh, I guess I forgot it. I wonder if there was a method to the madness there. The fact that I don't have it in both places makes me think there was a time where I was like, this makes sense. And I'm guessing because the behavior really wouldn't be different in any of the cases anyways, but nevertheless. Okay, cool. All right, so the above suggested layout, like I was saying, this strategy with the nested classes and all this stuff, you don't need to do it, but I think it's helpful for like I was joking, like the coping strategy. Test like blocks of the states, empty, singleton, many, right? And then each method for each of the states, you nest them. The before eaches kind of helps clean up the code a little bit. This is my recommendation. In general, you go out in the world and you start doing unit tests for collections. You don't have to follow this strategy, but I'd say it's a pretty darn good strategy. Cool? Cool. All right. Links. Okay. Now, warning. This topic is not, we are not introducing a new ADT or anything. Okay? Instead, we're introducing this new concept called link structures. And we can use these link structures, I mean, when we link them together, we can put these together and treat them as like a new container in a way similar to like an array. But at this stage, we're not making a new like collection or anything. We're only going to make this very simple concept of a linked structure. Arrays have a fixed size, right? But you know, we've got that expand capacity. When using arrays, data may need to be shifted around, right? Like when I add and remove something, like if I've got a giant array with 2 billion elements and I want to remove the billionth, right? I got to close that gap, right? So, you know, data has to get shifted around. So, you know, maybe we do that thing where we take the last element and put it in the middle, but what if order matter? You know, there are things we have to deal with arrays. And traditionally speaking, at least, arrays are in contiguous memory, meaning if you were to go like look in your memory addresses, an array would start at memory address x and go to x plus 10 for like a length 10 array, right? Or plus 9, really. JVM asterisks. In Java, arrays are objects, and objects are on the heap, and so there really isn't necessarily any contiguous RAM there. But in general, traditionally speaking, arrays are in contiguous memory. Okay? Cool. Some facts about arrays. But, you know, knowing that, let's think about, like, well, alternatives. And the alternative we're going to look at here is link structures. A linked data structure is one that consists of objects referencing other objects. So here's the idea. I'm going to have nodes. Do I have a? Yeah. And a node is going to maybe have some data associated with it, but it's also going to have a reference to a node. So first, imagine I have a reference variable to a node called head. That's this node. Here, note, this is not a node. It's a reference to a node. These boxes are nodes. Each box, one of its fields, will be a reference to another node. That's represented as this arrow. All the blue arrows are references to nodes. Okay? So this node is followed by this node, it's followed by this node, it's followed by this node, it's followed by this node. Cool. That's the idea. That's really the idea right there. Linked structures don't have a fixed size. Because I could go to this last thing here and be like, just add a new node, right? And okay, make a new node and have this one reference that new node. Like there's no expand capacity or anything going on. We'll see once we get more concrete here. And with links, with the linking idea, data does not need to be stored in consecutive memory locations. Right? Again, I know in Java the arrays aren't really in consecutive memory addresses. But like, You could have a node in RAM here that's referencing a node that exists in RAM over there, which references a node that exists in RAM over there, and it doesn't really matter. They don't need to be in contiguous memory addresses. Not that that's overly important for us to really be overly concerned about, but it's a fact nevertheless. Data can be inserted and removed by updating references too. There's no need to shift data around, right? Like, imagine I wanted to put something in here. Well, I could have like this reference the new one and then that reference that, right? Or if imagine I wanted to insert something at the beginning of an array. I would have to move everything down one, right? If there's n things there, I got to move n things. Here, I just, okay, make a new node and have it reference this thing. Boom, done. It's at the beginning. Easy peasy. Yeah. Now, we're going to make these linked structures. We're not going to make a linked structure class right now. We're not going to do that. We are going to make, like, spoiler, a linked stack, where we make a stack with a series of nodes. But right now, we are only making a node class. And we're going to manipulate nodes. That's it. Okay, there's no linked structure class that we're making at this stage. We're going to create a node. A node is a basic unit for these linked structures. We are going to focus on singly linked nodes, meaning there's only one link to it, okay? This would be like doubly linked, but we're not going to worry about that right now. Singly linked. Each node has one link and one piece of data. The series of nodes linked together is what makes a singly linked structure. Yeah. So this might be how you visualize a node object. We've got some node represented by this box, and within it, it's two fields. A field called data, which is a reference to something of type T. We're going to want it to be generic. What it is, I don't care, but it's some data. And it's going to have a reference to a node. Okay? That's it. That's all a node is the data and the next. That's all. Yeah?
So for essentially like a link stack, you'd essentially have the data.
Well, let's not jump to the link stack right now. Let's not do that. Yeah. I don't want to jump the gun. We're not quite there yet. Yeah?
If you want, say, to do a linear search into a link, would you be able to have the data, or the data is linked with the next node?
Y'all are being too smart because you're trying to jump. You're jumping ahead. Slow down. We're getting there. We're getting there. Yeah.
Here, I'll be now.
Perfect. Perfect.
I didn't really understand, so you said it was less complicated to use nodes for moving a bunch of.
I don't want to say it's less complicated. I'm saying if I had an array, you stop trying to be smart.
What?
We're getting there. We're getting there. You're jumping the gun. Don't worry. We're going to get right to that. I was only sprinkling ideas at you. Now you're jumping on those. Let's take a couple steps back and carry on. This is good, though. This is good. Your minds are going the right places. So this is it. We got data. It's a reference to some object that's just some data. And next, which is going to be a reference to a node, a successor node, though. All right? Arrays don't have this. So, okay, data, think of an array. Let's do the analog here to the array. An array is a series of information, right? So for a node, the data stored in the node would be like, what are we putting at that array location, at that index, right? At index X, I'm putting some data Y. Data would be Y in that example, okay? It's just, what are we storing there? The next, arrays don't have, because arrays just intrinsically have a next by virtue of how they're laid out. If I'm looking at array index I, and I want to say, what's the next one? I plus 1, right? There's no next because it's just there, right? If I wanted to say, what's the next? Well, that would be I plus 2, right? Arrays just have this built in. So that's what like the next is, right? The next is the successor. Arrays don't have this because each cell is adjacent to its next one, okay? And the indexing of the arrays is how we achieve that, moving around that collection.
Wait, so are like linked, like whatever, like linked structures more close to lists than arrays are?
Nope.
They don't need
No. And you are making a common blunder. A linked structure is just a linked structure. A list is an abstract data type that could be implemented with any underlying container. A linked structure can be used as a container. An array can be used as a container. Various other things can be used as a container. But a list is just some general idea. So like you're saying like, oh, would it be more like a list from Python, I presume you mean, because like, oh, it can grow arbitrarily. The country catalog you made with an array can grow arbitrarily. So like we didn't need this link. Like no, there's nothing there. In fact, we'll get there. We'll get there. I didn't want to spoil the fun. So like great that you're thinking that, right? But the mistake is, and in fact, I'm being very careful here. Usually, this is a very unfortunate collision of jargon, okay? Often, and even for the textbook for this class, but often, people will call linked structures linked lists. But that's a mistake, especially when using Java, because a linked list is a list made with linked structures, but a linked structure is not a linked list. It's a very bad name. So I'm being very careful to call them linked structures to differentiate between a linked structure and a linked list, right? You can make a list with linked structures. You can make a list with arrays. That's fine. But a linked list would be a list data structure where you can add, remove, insert, all the stuff you did in Python, for example, on a list. You could do that with a linked list, just like you could with an array list. A linked structure is just a series of nodes. There's a lot of extra crap that the lists can do. So when you see linked list, you might be seeing people actually meaning a linked structure. It's a very unfortunate collision. And what makes it more unfortunate, I would say, is the fact that they are related to one another. So when you have this collision, this ambiguity of these words to two things that are very related, it's that much more confusing. I doubt you're going to have issues in this class because I'm going to call it a linked structure. But warning, if you're going to read Wikipedia or something, you might see that wording used. Bad wording. Yeah. It's made worse by Java because Java's naming convention when making collections is like, we had a stack, right? A stack was the interface. But we made a very specific implementation of a stack called array stack. So in Java, the convention is like container, strategy, whatever, name of the thing. So array stack. We're going to make a linked stack. So we'll have it linked stack. On assignment 1, you used a hash map. Hash was like the way. Map is what it is. We're going to make so you can go make a list called array list. It's a list made with an array. You could also make a linked list, which is a list made with a link structure. And so there's that Java convention that messes it up again. So it can get hairy. It usually isn't a problem for students. I'm just warning you that if and when you come across it being named, poorly, it is what it is. Also, some people on the assignment used array lists instead of arrays. Don't do that. An array list is a list, okay, made with arrays. And people go like, well, why would I use an array? Because I have to do expand capacity. Array list will grow on its own, so I don't need to do that. The point of this class is we're making an array list with arrays. If you open up the hood of an array list, you're going to see an array, and there's going to be an expand capacity in there. That's what we're making. That's like my analogy of like, you don't take a class on how to build a car and then say, why would I build a car when I can go buy a car? Because you're taking a class on how to build a car. Why would I build an array stack when I can go import array stack? Because we're learning how to make an array stack. Anyways, rant over. I'll catch you all later.